Today's episode is brought to you by SVS. Based in Youngstown, Ohio, SVS delivers thrilling and immersive audio experiences from their highly acclaimed speakers, subwoofers, cables, wireless audio gear, and more. SVS is leading a sound revolution by offering expert support, generous owner benefits, and a world-class performance that far exceeds the price. Learn more at SVSOUNDdotCOM. That's S as in speaker, V as in volume, sound.com. Today's episode is also sponsored by Schiit Audio. Schiit Audio designs and builds audio components in California and Texas. Based in Valencia and Corpus Christi, their wide line of amps, DACs, and audio accessories fit any budget, starting at $49. For a full rundown of all their products, visit SCHIITdotCOM or stop by their retail store in Old Newhall, just north of Los Angeles. That's SCHIITdotCOM. Today's episode is brought to you by Musical Surroundings. For over 30 years, Musical Surroundings has distributed high-performance analog playback equipment to vinyl enthusiasts and music lovers throughout the United States. Based in Oakland, California, Musical Surroundings represents world-class brands like Clear Audio, Hanna, DS Audio, and their own line of Musical Surroundings phono preamplifiers. To learn more about the exceptional turntables, cartridges, and analog accessories they offer, visit musicalsurroundings.com. That's musicalsurroundings.com. Hey everybody, thank you so much for joining us. Today's show is The Anatomy of an Amplifier with Jason Stoddard of Schiit Audio. Thank you so much for joining us, Jason. How are you doing today?
Good. So, if we're talking anatomy, I guess it's the the mouth to the bowel movement of Schiit.
But first things first, before we get into all that, I do want to know, what wine are we drinking tonight? Most importantly.
Okay, since I'm in Texas right now, gotta go Texan. It is actually a Pedernales Cellars Family Reserve 2018. We're going through the Texas wines now and learning the A's and B's, ins and outs of those. With respect to California.
And generally speaking, how does Texas wine stack up against California?
Okay, this is a very early generalization based on one trip out to Fredericksburg and a little bit of wine around here. Think Santa Ynez 1990, or for people who haven't lived their whole life in California around the whole wine thing, it's like they're discovering what they can do. There's a lot of potential. California is still going to, probably be the primary in the U.S. As far as if you want super crazy, expensive, great wine, you're probably going to go to California. But Texas is showing a lot of promise. It's interesting because you can go to Oregon, you can go to Washington here in the U.S. and that they're more accepted. Actually, Texas is doing some really good stuff as long as they stick to what they can make. But then
what's the grape varieties they favor there? Because I know it depends by region, right?
It's going to be hot weather stuff, typically what you'd see in southern Italy and in Spain. So you're going to see Tempraneos, things like that. You're probably not going to see a lot of Cabernets. Well, not good ones. Just to be 100%, up and up. On the white side will be Viognier rather than Chardonnay. Unless you're a wine geek, this probably doesn't mean anything. But we are wine geeks, so we're learning what's good here and what's good in California. I drank wine in Japan. It's like I went to a place in Japan. They actually make French style red and white wines in Yamanashi. And one of the most fun things we ever did was we went there and tried the wines there. And for 1,000 yen, they give you a cup. You can try 300 local wines. Hopefully not all at once. I don't know if they get many Americans there. It's kind of out in the sticks. But yeah, it's a kind of recipe for disaster depending on who you hand that cup to. But Japan has some good wines. Texas is going to have some really good wines. California has great wines and shit wines. Oregon and Washington do a good job.
Temecula.
Yeah.
Something
I don't know if we're allowed to
something in my throat
shit all over California, but yeah, Temecula, I've yet to have one that's interesting.
Oh, we're going to get a call from the tourism board on that one, but lovely place to visit. I've had amazing times in Temecula, let me just say that.
Hey, if they want to have me out to Temecula, I'll be happy to comment on some wines. Just please serve me something that doesn't taste like a dry port, and I'm good.
Here's my one tip. If the tasting room is free, you might want to avoid that one.
Yeah. There's also some... In Texas, there's also some stuff that's kind of clearly aimed at... I'll be polite. New wine drinkers. They'll have like flavored wines, like coconut flavor. I'm like, yeah, okay, that's good. Not going there.
Like the old Boone's Farm, right? Banana and strawberry. Everybody loved that one. What a great combo.
Ooh, yeah. Oh God, yeah. Strawberry Hill. How
you're
can
right.
you forget
Strawberry
that?
Hill? I was thinking Mad Dog 2020. My bad.
Mad Dog 2020. Yeah, Mike likes to mention that one. Oh, yeah.
Banana strawberry.
No, I mean, give Texas 10 years, it might be fairly frightening. So, or we might all be dead from climate change. I don't know. We'll see how it goes.
Either way, right? Either way. Today's show is also sponsored by Wharfedale. For nearly 90 years, Wharfedale has built loudspeakers for music lovers all over the world. With a warm and natural sound signature, their inherently high-fidelity sonic retrieval simply makes you want to listen to your music for longer. Visit WHARFEDALEUSA.com to discover the high-value Diamond 12 series, the best-selling Linton Heritage, and the no-holds-barred Elysian. That's WHARFEDALEUSA.com. So the anatomy of an amplifier. The first question I kind of want to ask you about on this front is, once we have our signal, right, we're going to take it from a turntable if it's analog, or we're going to take it from a DAC once it's transferred from digital back to what we call an analog signal. In your best words, what's the best way to explain what that signal really is? It's a signal. It's got electrical current going into the thing. What is it outside of just that?
Oh God! If you get down to Fourier transforms, it's a collection of sine waves, which really means it's a complex wave that has both positive and negative components around this imaginary zero level that we call ground. There's going to be, if you actually run something into a speaker, it will go to, say, like 2 or 3 volts on the high side and 3 or 4 volts on the low side, and back and forth. That's what makes sound.
So you're saying it's a function. It's function of voltage. So it's a voltage that goes up and down.
Voltage and current, because can it drive the speaker? That's one of the key questions, and that's why you don't have a turntable, going to a speaker, or a DAC going to a speaker. It's like, okay, how do we manage this raw voltage output? Because neither of those is going to be particularly powerful, especially turntable. Turntable is going to need a specific kind of preamplifier, phono preamplifier, that has some frequency shaping in it as well. And A phono signal is going to be very small, typically. It's going to need 100 to 1,000 times amplification before it even gets to line level, which is usually what comes out of a DAC. And then it will need more amplification to run a speaker. It may not need more amplification to run a headphone, but a speaker, absolutely, you're going to want more voltage. If you look at it in rough terms, you might get a couple of millivolts or a couple thousandths of a volt out of a turntable. You'll get 2 volts out of a typical DAC. A speaker might need 20 or 40 or more volts, to actually, reach its full potential. And that doesn't sound like a lot more, but when you start talking about the amount of current required, it rapidly builds up, because 2 volts into, say, 100 kiloohms or 10k ohms, 10,000 ohms or 100,000 ohms isn't much current. If you're talking 20 volts into like a 4 ohm speaker, suddenly you're talking like many amps of current, and that's kind of the whole thing about an analog amplifier, or an audio amplifier will be like, how does it interface from either a phono source, which is very low level, or a DAC source into a headphone or a speaker? Headphones don't typically need a lot, and in fact, our least expensive headphone amp products that do a couple of watts into a headphone, it's ridiculous. That's an amazing amount of power for a headphone. It's probably somewhat akin to a 1,000 watt amplifier for a speaker. It's above and beyond anything you'll ever need, unless you happen to have a weird headphone. Hi-Fi Man got famous for the HE6, very hard to drive. There are other headphones that are very difficult to drive. Those may need some more, but if you're talking your typical headphone, holy moly! I mean, a Magni will light it up. A lot of amplifiers from other manufacturers that do even less power are going to be just fine with most headphones.
Do you think that generally speaking, it's easier to develop a good headphone amplifier than it is a good speaker amplifier?
I think you have more options. Speaker amps, if you're talking 8 ohm speakers, 4 ohm speakers, or in the case of some speakers, they get down to 2 and 1 ohm, at certain frequencies, you're limited in what you can do. You have a limited amount of topologies you can play with, because you need to do a lot of volts and a lot of current. So you are probably going to be using feedback if you're using a Class A or Class AB topology to get the output impedance down. You're probably going to be using feedback. Well, you're certainly going to be using feedback if you're using a Class D design, which is some people have called them digital amplifiers. They're not really. It's a more of a switch mode type of amplifier. So you're profoundly limited. If you want to do a Class A speaker amp of any like decent size, above 20 watts, 20, 30, 40, 100 watts, they're huge. I mean, they have to dissipate a ton of power. If you want to do a Class A headphone amplifier, oh sure, it can be tiny. It's not that big a deal. Class A headphone amp is a lot easier. If you wanted to do a single-ended, speaker amplifier, that's very difficult because it's going to have horrible distortion performance. It'll probably have really bad output impedance. Won't interface well with a lot of speakers. You want to do a single-ended headphone amplifier? Sure, no problem. Because you're really driving something that doesn't take much power. And that's one of the reasons we started with headphone amps. Is like, finally all the stuff I wanted to play with at Sumo, it's like, oh, I can actually play with this. I can actually do amplifiers that are crazy. I can do circlotrons. I can do single-ended stuff. I can do Class A. Whereas the Sumo did one Class A amp that was 100 watts of channel, weighed 80 pounds. It was 27 inches deep and 8 inches tall. I mean, the thing is huge. It's really orders of magnitude between headphones and speakers.
So as the signal that we talked about comes off the turntable and the DAC. It enters, either a single-ended output or a balanced output in the back of the amplifier. And we're going to, for all intents and purposes in this, we'll stick with integrated amplifier as opposed to two separates, although they would work the same in this kind of execution. But when it enters in, we're looking at an input stage of some type. What typically happens at that point in the signal path, and what are some of the best ways people have managed it at that point?
Yeah, and honestly, it can go both ways. You're not necessarily looking at an input stage. For example, not to sell our products, but like Ragnarok 2, it's a single stage amplifier. There's not multiple stages. It goes into one gain stage and then out, unless it's a turntable input. And then actually there is another stage. So there's the phono preamp stage, which gives you that 100 to 1,000 times gain you need for a turntable source. It also gives you what they call the RIAA equalization curve. So you actually need to equalize a phono preamp. They actually bring the amount of bass down and treble up on when they actually put something on a vinyl record, and then you have to bring it back to flat. That's a different thing. And that in the case of Ragnarok, it's a separate card. In the case of an integrated amplifier, typically if it has a phono preamp, it will have a separate section that just does that step up to line level. Line level being, say, 2 volts RMS, fairly typical, just to match what you're getting, say, from a DAC. A typical DAC will be 2 volts RMS out. And then it could be run through a separate preamp stage and then an amplifier stage, which a lot of integrated amps do. In our case, we have one amplifier stage that has enough gain to actually do the preamp and amp stage in one. There's not necessarily a first stage. But if you're talking about in a discrete amp, if you're talking about the first stage of that, then yeah, it's small transistors, then bigger transistors, then large transistors on the output of a typical Class A or Class AB amp. Class D, I can't talk a lot about. We've experimented a bit with it, but we're not the experts on that. That would be, talking to someone else about that.
So at some point, that signal needs to be regulated for volume, and that particular section I know can be very precious. I think everything is precious, but would you say maybe the signal is more precious when it's at that 2 volt stage? Once you get at line level, is it easier to mess it up when it's just like a tiny little thing?
Well, I think you can mess it up anywhere, but at lower levels, it's typically tougher. That's why a phono preamp is really tough. That's why phono preamp, we spend a lot of time making sure it's low noise, low distortion at very low levels, because that's what you need. Hilariously, of course, a phono source is not, it's not state of the art as far as measurements go, but you actually have to pay a lot of attention, because if you have a phono preamp that's like, people don't want to listen to the hiss, they don't want to listen to the hum. You want a quiet phono preamp, and to get something that's quiet and has 100 to 1,000 times gain is a neat challenge. But let's say we get it to 2 volts and it's good, or we got 2 volts out of a DAC. Then, if you're not into audio, you might think it's kind of weird. Then we throw away a lot of that signal. We run it through a volume control state, which is typically a potentiometer, or you can do it with, there are integrated circuits that actually do volume control as well, or you can do it with a relay stepped attenuator like we use in some products. But you take a lot of that 2 volts and you throw it away, because 2 volts times, say, a gain of 20 is 40 volts. That's going to blow up most speakers, out there, or it's going to be right at their limit. So you need to bring down the level. And, to us, we like relay attenuators, because relays are just resistors and switches in the signal path. You can also use a potentiometer, which is a variable resistor. It typically has a element that goes on a carbon film or a plastic film, and it actually attenuates the signal. Those can work very well as well. They're also essentially the same thing as our relay attenuator, but on a chip using MOSFETs to switch things. We don't like those as much. There's some limitations with that as far as the amount of input level they'll take. And it's funny, you typically don't see those in the highest performing systems, simply because the measurements aren't quite as good as what you can get out of a pot or a relay attenuator. So the first stage would be to either accept the 2-volt input or step it up to the 2-volt input in the case of a phono. Second stage would be, let's control the volume in some way, which is hilariously throwing away most of your 2-volt signal once you've got it. And then there would be an amplifier after that that drives the headphone or speaker. And the amplifier stage is typically a fixed gain, or it'll be a limited number of fixed gains. A lot of our stuff will have like low gain and high gain, or low, mid, and high. But it's not like you're going to vary the gain of the amplifier stage. Though you can do that. I mean, there are topologies where you vary the gain of the amplifier stage. We haven't played around with that. I can't comment on that very much. I just know that is an approach that people do take.
So typically when you're at that stage, there's a lot of different, what I think they call topologies that you can employ, especially when it comes to tube amplifiers. We've done a podcast on tube amplification and all of that, many variations. To keep things simple in this execution, what are some technical differences that people can do at that amplifier stage in the solid state realm? There
are a lot of things you can do. Most amplifiers are going to fall into one of two classes. It'll be either a class A or AB type topology, or it'll be a D. D is what we call a switching amp. It uses pulse width modulation to be a very efficient way to amplify. We don't particularly like it that much because we think that it needs to switch at a much higher frequency for it to be, truly representative of the input. But suffice to say, other people may be getting great results with it. It's not our thing. So let's talk about A and AB and all the variations of that, because when you hear someone talking about class A or class AB, they're talking about the output, the output stage of this amplifier stage. And it's like, does it drive the speaker or headphones with output devices that are always on, that's class A, or that switch on and off, which is class AB. There have been many arguments, and the thing is, we've muddied the water. We have our own what we call continuity, which is our take on how to make an AB act more like A. If you have infinite time, power, and money, class A is probably great because let's see, the Sumo 100-watt Class A dissipated about 1,200 watts at idle. So that is a room heater. If you'd like a room heater, like for one channel if you run it mono, if you want 2 room heaters in your room, or say 5 if you're doing home theater, or 7, or 16, or whatever, how many channels you're up to in home theater these days, have at it, man. That's great.
That's primarily because when the amp is actually not providing power, that power has to be executed as heat. Is that correct?
Yes. A Class A amp will run cooler the harder you drive it. The more power it sends to the speaker, the cooler it's going to run, typically, because it's not just sitting there burning the power. The advantage to a Class A amp, and the reason people do them, is the output transistors never switch off, which means it never goes through a shut-off region where the transconductance is not as linear as it could be. You have to manage that if you do Class A B. So there are actual advantages. It's just that they're not the most efficient thing. If you're going eco, or if you have solar panels and batteries, you may want to factor in the amplifier current draw. No kidding. If you're doing Class A, so most amps are going to be Class AB. Class AB means that the outputs are biased to a certain level of Class A, and then it switches to Class B, which means one side is off while the other is on. If you manage it well, it's not a horrible thing to do. It's been done for decades and decades, 50 years now, really. It's really what the majority of amplifiers are. If an amplifier is not Class D, you're going to pretty much expect it's going to be a Lin topology Class AB amp, meaning it's a voltage feedback Class AB amp, meaning it does have feedback. It will switch off. It has a certain type of differential input that's used, because then you have a nice place to have the feedback. That's going to be 95% of everything that's not Class D. Ironically, we make exactly 0 of those. Not to get into a sales pitch, it's just to describe the differences. Our stuff is what we call current feedback. Current feedback rather than voltage feedback means it's not a differential input stage. If you're say looking at a Vidar or a Magni, actually a Magni and Vidar are very, very similar. One's for headphones, one's for speakers. It's a very, very simple topology. It uses a non-differential input, and it uses a very low impedance feedback network, which allows it to be a much faster amplifier. Now, it also has lower power supply rejection and not quite as good distortion. So you can get into all sorts of arguments about what's better? Should it be faster? It should be lower distortion, or should it have better power supply rejection so it's quieter? Should you have this? We like current feedback in general. We like the way it sounds, and some people are going to go, "Oh, sound is sound is subjective." Yes, it is. There are plenty of other options out there. But we also do other amps that are balanced. Ragnarok 2 is a topology we call Nexus, and it's actually balanced in, balanced out. We used to do circlotrons, which is another kind of balanced in, balanced out topology. There are a lot of options out there. And for the affordable amps, we've kind of settled on, we have this nice current feedback, really simple gain stage that's in everything, literally from Magni to Loki to Vidar to Azure. And then we have this wacky thing we call Nexus, which is used on the balanced side of things. It may complicate your discussion to talk about balanced versus single-ended, but there are advantages to both.
What would the advantages to single-ended designs be over balanced? Because I think a lot of the production end of things uses balanced exclusively for things like microphones, not guitars, but a lot of long runs of cable are usually recommended to be balanced. What are some of the advantages of single-ended in these designs? And if you got something outside of what I just recommended for balanced, that'd be great too.
Yeah, okay. Single-ended amplifiers are typically going to be simpler, which is an advantage in itself, just because it's easier to produce, it costs less, etc. They'll also be quieter. One of the things you'll notice is if you look at phono stages, there's really no balanced phono stages. There may be some phono stages that are using a balanced input, but they typically won't be processing in balanced, because you're looking at 6 dB more noise in a balanced situation. If you want a really quiet amp as far as thermal noise, the hiss, not necessarily the hum, but the hiss, a single-ended amplifier will have an advantage there, and it's fairly significant. That's why on the phono side you really don't see much in the way of balance, not true balance anyway. Balanced will have an advantage in that the hum components, the stuff that you hear coming out of the AC line, that noise, it tends to fall out because it will cancel. It can have an advantage in slew rate. That's kind of an old argument. I don't really, give much credence to that. We tend to like the way balanced output amps sound, and again, people will be like, "Well, sound doesn't, it's not measurable." I'm like, "Yeah, I know, I get it, but I like the way Ragnarok 2 sounds. I like the way Jotunheim 2 sounds compared to some of our single-ended stuff." So it's purely subjective. I may be fooling myself, and I'm a manufacturer, so you should actually suspect me whenever I say buy something that costs more than the other, right?
Right. There are a lot of types of transformers used in electronics, but one particular type that seems to be very frequently used in the higher end, or at least the mid-range too, for audio is toroidal.
Toroidal, yeah.
It's a tongue twister of a transformer. Why is that one such a popular option in audio equipment specifically?
Because they look cool.
That's good enough for me. Next question.
No, actually, I'll talk a little bit more about it. Mike hates toroids. He's like, they don't have any bass. They don't sound. I'm like, Mike, they have advantage. It's like everything. It has advantages and disadvantages. Toroid transformers are those round atomic donut-looking things that you see in some amplifiers, rather than the old school stuff you see inside of I don't know, an old lighting box, where it's like a square transformer. They have advantages and disadvantages. We switched in Ragnarok 2 from a conventional, what they call an EI transformer, to a toroid because we had problems with the EI being noisy. We had problems with the EI having radiated magnetic field, which made the amplifier noisy. So we went to a toroid that solved all that. Mike's like, well, the bass is still blah, 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 blah. And I'm like, yeah, that's nice. The bass sounds fine to me. Also, it's quiet. So people seem to really love the toroid in that application. They're typically harder to wind because it's a donut. You're wrapping wire around it. Have fun with that, versus something where you do the coils and you put the EIs on it and call it a day.
Yeah, if you open up the case on these guys that have them, you can see that like half the space inside the case is usually for this giant black donut you're referring to.
Yeah, or more. I mean, it's crazy. I mean, if you're doing a Class D amp and switching supply, you don't even need a transformer. You can do an offline switcher to a Class D amp. It'll be very efficient. It'll run very cool. Again, you get lots of arguments about what sounds better. To us, we don't like them as much, but we may be crazy.
Yeah, I mean, I've seen them in a lot of different components. I mean, at least the CD players, the source components, tend to use them if they're a little bit on the higher end. So I know that like a lot of people favor them on that side. I'm not sure I'm always peeking around looking for them in all the big amplifiers, but I'm assuming that they make their way into a lot of those designs as well.
Here's the thing, Mike loves his conventional C core and EI core transformers. I think they're actually best for most applications. For some things, a toroid will give you higher energy density, or it'll have lower field, so it'll be quieter. In those applications, it makes sense. We haven't played around a lot with switching supplies on the amp side of things. That is something that may come down in the future. And then you'll have to open up the box and it's like, where's the transformer? Well, yeah, maybe there isn't one.
Another element of like a hardware element that's often talked about is the capacitors that are used. Are there any like tips, tricks, recommendations that you feel revolve around capacitors, like choices?
I think it's overblown a bit. We typically choose stuff that is higher temperature, it'll last longer, but we don't get into that very much. But we also don't design anything that has coupling capacitors. It typically won't have capacitors in the signal path. It won't have coupling caps. We don't have to deal with that. So you're talking power supply stuff. So power supply is not that interesting. Now, what is interesting is we have a couple of products coming out that actually use what Mike calls a choke input power supply, which means at that point you take a transformer, or an inductor that's the size of the transformer, and you run the transformer, literally into the bridge, into the choke, and then into the power supply. This results in a much better filtered power supply, and now you have this giant hunk of iron that's storing energy rather than a capacitor bank. So Mike would always go, choke input's the way to go. And based on some of the stuff we've learned, it is. We have an amp coming out hopefully in a couple of weeks called Tier, that is a 200 watt per channel into 8 ohms, 350 watts into 4 ohms monoblock amp that has like a 12-pound transformer. It has a 12-pound choke sitting next to it. That is the result of like 30 years, literally, of Mike bugging the living piss out of me about like doing a real choke input amplifier. Literally 30 years ago, I was in his listening room, trying to make a sumo amp sound better than his cellos. And he's like, I should stick a choke in it. Use a choke input. And I'm like, what is that even, Mike? And he's like, no, a choke input power supply. It's like God's power supply. That's how they're all supposed to work. And I'm like, I don't know what this means. So I tried it. We eventually ended up killing these cello amps with like a $550 like sumo amp with a giant choke bolted on the outside of it. And so ever since then, he's like, when are you going to do an amp with a choke input? I'm like, Mike, these things are stupid. No one understands them. They're going to think they're low power. And he's like, it doesn't matter. They sound good. So we're finally going to do one that has a big transformer, a big choke, and so everyone's either going to be happy or they'll look at it and go, you want what for what, and how much does it weigh, and are you stupid? I don't know how that's going to come out.
Well, another technology that people often use, or another technique rather, that people often use in power supplies is taking the power supply and putting it in a separate box entirely. Do you find that design has any advantages, or is it really just, can it be done in a single box design just as easy and just as efficiently? Because I believe the main reason for that is to isolation and to reduce the noise floor and yada, yada, yada.
Yeah, and actually, hilariously, a lot of the time, the transformer, it'll have stray magnetic field, which is what's going to cause a lot of the noise. And the stray magnetic field in the plane of the board, the X and Y dimension, is typically fairly low because transformer manufacturers know, you typically don't want this going into the board. In the Z dimension, up and down, it might be really big. So if you're doing a separate power supply and then you're stacking the thing on top of the power supply, you may be defeating your whole purpose of doing that. That has been our experience. That doesn't mean that's everyone's experience, but I remember very vividly designing a preamp for Sumo where I'm like, this is a great idea. We're going to have a separate power supply, you put on top of the power supply, and as soon as you actually put the thing on top of the power supply, it started humming like a mad dog. And I'm like, this is great. And, my boss at the time was like, so what are you going to do about that? I said, just tell them to stack it away from each. And he's like, everyone wants to stack it on top of, the other thing. I'm like, yeah, I know, but that's the solution. He's like, so do you feel stupid now? I'm like, yes, I feel really stupid now. So you made your point. We'll start putting everything in one box. So we haven't done anything with a separate power supply yet. If we find a reason for doing that, we will, but not yet.
Only in one product have I ever seen actual circuit board, like the board that the stuff lays on, be touted as a part of the feature set. Oh, this has this XYZ branded circuit thing. What are those board? I'm sorry. What's the technical name for the board that you just weld everything to?
The printed circuit board. Yeah.
Yeah, it is a circuit board, right? Okay, good. I thought so. Yeah, so I saw it touted once as like, we have this branded circuit board. in your experience, does that make any difference? And should there be different levels of circuit board quality?
Yeah, not to give away all the secret sauce.
Yeah. Okay.
But there are different types of PC board. There are many different materials you can use. One of the things that Theta used to do back in the day is they put the analog section on a Teflon PC board, which was really interesting because back then solder mask wouldn't stick to it. So you're talking about like now it's a hand soldered PC board. It was completely insane. And Teflon boards in that day, they weren't reinforced, so they're kind of like gloopy. I mean, literally, they're kind of like, it's like building on Jell-O. But Teflon boards seem to actually give Theta an edge, and we not to give too much away, we've paid attention to PC board materials, and some of our PC boards are on weird materials that we don't really talk about.
Sure.
It is interesting. There are a lot of options these days, and in fact, if you look at the dielectric constants of various board materials and the different board materials you can get from the Teflon stuff and the ceramic stuff and the polyamide stuff, the regular FR4s, they even have different variations on that. There's a lot of options there, and it's not just snake oil. It's like a lot of stuff. If you're putting it on something that has a different dielectric constant, it will perform differently, and you will be able to measure that. So there is something to it. It's something I don't think a lot of manufacturers want to talk about. There are certain things we do, like with that and with parts, that it's not worth talking about. Let someone buy it and reverse engineer it if they want to deal with it. But I'm not gonna put that in our marketing.
Another term that's used in marketing very often, at least I haven't heard about it as much, but it used to be, is point-to-point soldering. What is point-to-point soldering, and are there any benefits to that?
Before there were printed circuit boards, everything was point-to-point. And in fact, my first audio company boss, Ed Miller, I think he headed up the first color TV assembly line, like in America. And he's like, we were literally doing the stuff, soldering at point to point, meaning we're running wires, on the bottom side of like these tubes from like tube to tube and from component to component. And then we'd have to like twist them, and we'd have to tweak them, and we'd have to, use all these things to actually tune it up to try to get the color out of it. And he said eventually the color TVs were all recalled because they didn't really work. Point to point is a way of doing very simple products. It's popular in tube amps, and that is a way to do things. We can't do it because a lot of our stuff will have 150 to 900 components on it. A complex tube amp might have 30 to 60. The thing is, if it's done right, it's a great way to do things because you have complete control how things are routed. It's wonderful. It is a viable thing to do with tubes. With solid state, I don't know. But point to point, it's it is a thing. It's just you're going to see it in tube amps really rather than solid state.
Now, the point-to-point wiring, there's electrical current that travels through different wires and such, and the boards itself. A lot of emphasis is often made on cables in audio that travel from component to component. Do manufacturers, or do you in particular, pay attention to the wire that's used inside the amps, or is that something, and you can also go ahead and throw your stance on the outside cables, but does it make a difference from your experience on the internals?
We pay attention, but more on the scientific side. It's like if we're doing a power amp printed circuit board, if it has if it has anything that carries a lot of current, you'll typically do that at a higher copper density. You'll essentially say, I'll do a 4-ounce copper PC board rather than a 1-ounce copper PC, meaning the copper's thicker. Mm-hmm. And then when you connect it to the the output jacks, we'll use good 16, 14 gauge, oxygen free, copper. It'll be decent. It's not going to be anything fancy. It's not going to be anything crazy. And that's kind of where we keep it on the outside of things. We don't have a lot of opinions on cables. We'd much rather let the cable manufacturers do their thing. We try to make sure that we can transmit the maximum amount of power. And actually, hilariously, we've had some really interesting prototype stuff where prototypes are usually done on thinner PC boards because you can get them faster and you can kind of get an idea of what works. We had one prototype tube headphone amplifier that drew over 7 amps of current to run the heaters on the tubes. And I was like, why, boy, this transformer we got is total junk. It's garbage. I mean, it's only putting like 5 volts on the tube. It's supposed to put 6.3. And it's really funny. It put 5 volts on the tube, put 6.3 out at the transformer, and the internal traces were dropping so much voltage and getting so hot you could see them on a thermal camera. Wow. It was like, okay, you can get the wiring profoundly wrong, both on the board and off the board. We try to get it right as far as like amount of current it needs to take and radiated noise. Beyond that, we don't get too fancy, but we may be weird.
Of all the kind of parts and components that we've talked about so far, what part and component do you feel that we haven't talked about makes a large impact in terms of the quality of the sound in regards to like maybe the quality of the part or a unique sound it produces?
If you're talking about a discrete Class A or Class AB power amp, I'd say the actual power transistors, and the small signal transistors that make up the circuit, and the resistors. It is interesting. Resistors have a thermal and voltage coefficient. You want to keep that as low as possible. You want to actually have resistors that are typically like thin film, very low voltage and temperature coefficient to keep it actually as accurate as it can. It can be. With transistors, again, you can actually look at the linearity curves of transistors. You want to look at that and decide, even if it's not an audio product, do you want to use this for audio? There's stuff that is just horrible looking. It drops off at both ends, and there's stuff that's very flat, and you would like to use that. And that's really important these days because a lot of stuff is not built for audio use anymore because we've kind of moved on. Audio is considered largely a solved thing, amongst many engineers. I don't think it's solved. I think that there's still a lot of mysteries. And one of the things I do look at is the curves. How linear are the output transistors? How good are the resistors? We will pick very specific products for that, and we'll actually say this must be this product rather than substitute anything you can find. And we find that actually probably more important than say the power supply capacitors, things like that.
Of all your tenure in this business designing amplifiers, what was one thing that you thought wouldn't make a difference at the beginning of your career to something that you've discovered makes an immense amount now?
God, it sounds like a joke. Compensation. It sounds weird. It's for an engineer, it makes more sense. When you design an audio power amplifier, before you actually close the feedback loop, you take a look at what it's doing very far out, beyond where it starts rolling off in frequency. It might start rolling off at, say, 100 kilohertz. But what does it do at 100? What does it do at 200? What does it do at 1 megahertz? What does it do at 5 megahertz? What does the actual gain versus frequency plot look like? And can you get that as linear as possible? Can you get that as a nice, smooth 6 dB fall off, like forever, and as far as you can measure out? That makes a huge difference, and that's like, I had no idea. When I first did that, and this was back in the days when Mike's like, put a choke in it. I was playing with compensation, and I did the compensation really right on one of the amps we did, and Mike's like, wow, that's totally different. What did you change? I'm like, 2 capacitors. But you get them right. And when it's right, it's right. When it's wrong, it's... I like to say it's fairly easy to hear, but we're super picky. I mean, we're like crazy coffee people or wine people. You taste things that other people may not taste. So it really surprised me what compensation did. It really surprised me, when we got the choke input power supply going, what a huge difference that made. Even though the amplifier power went down, there's actually, you can get less power out of it because it's going through a giant choke. It's choked. I don't know. A lot of things matter. That's why I don't discount out of hand wire and cable and stuff like that. It's just that we don't want to get it. We don't want to really get into that because we value our sanity, I guess.
Not me. I like to go a little crazy once in a while. So on the flip side of that, what is like one of the biggest mistakes that you keep seeing over and over again, either in consumer audio, like mainstream audio design in terms of amplification, or even in our precious little audiophile sector?
Wow, in both. It's actually treating audio as a solved problem and repeating the same thing over and over. It's like I mentioned that if you're actually looking at audio amplifiers, 95% of them are going to be a Lin topology, Class A or Class AB. Typically Class AB. It's like you can pretty much say 95% of everything is Lin, Class AB, done. It works. Is it the best? I'm not 100% certain of that. Why are people not trying some different things? We tried different things. We started with Lin, say on the original Magni was a Lin topology amplifier. Then we went to actually a current feedback topology. And I'm like, wow, this is way better. And that's where we ended up. There's lots of other approaches we could take within the constraints of actually being able to drive something. And it's a lot easier on the headphone side. So I see the same thing over and over. It's like, okay, it's a Lin topology, Class AB, typically with coupling caps because you don't want to hear like the volume pot, changing things. And it's like, this gets really old, and I've seen stuff like that being sold for just ungodly amounts of money. It's like, guys, maybe try something new, try something different. And maybe it'll be good. Maybe it'll be terrible. I don't know.
Do you feel that amplifier design was more creative 20, 30 years ago, or is it more creative now?
More creative now. People are trying new things. The headphone amp market has actually cracked things more open. So now, people are looking at like, well, okay, if I can do Class A for a headphone amp, if I can do Class A single end, can I do that for speakers? And in some cases, they're like, oh, this is interesting. I can actually do this with a fairly efficient speaker. And then you also get people that are like, I can do this for a speaker that's used near field, which starts getting a lot more interesting. And then you actually start getting people realizing, well, maybe I don't need a ton of power to run a speaker if it's near field, and especially since, hey, I live in an apartment, I can't run it that loud anyway, so maybe I want to go for, take your pick, quality or euphonic, whatever, however you want to do that. But you can do different things because it's not always about like, can I run my home theater at 135 dB, using 10,000 watts of power? And I think people are starting to realize that. So it is more interesting now.
Before we kind of finish up here, I did want to rehash one thing we talked about in the last interview, because we've done a couple of interviews together here on the show, but the potential of Class D to be something other than the cheap alternative for the mainstream amplification. Do you think that the ultimate finish line for amplification topologies lies within a refined Class D or something else that we haven't discovered yet?
I think it's something else. I think Class D can be really good if it is actually incorporated into a powered loudspeaker. If you know what load you're actually driving, you have a leg up because you can do a really good, filter topology just for that particular driver. And plus, a lot of times you'll just be driving one driver, just tweeter, just woofer. You have huge advantage there. A general purpose Class D that you can hook up to a 12 ohm zoo and also a KEF that hits 1.8 ohms at certain frequencies, that's a whole different ballgame because the output filter becomes a huge factor. I haven't found a way around that, and we haven't actually achieved the switching frequencies that we consider necessary to do a high quality Class D. Now, other people may be able to do it, but not us, not at this time anyway.
And as we kind of wrap it up here, I just wanted to ask you one more question. What do you think is like the number one thing that people should look for when purchasing an amplifier? Or maybe the top 2 or 3 things maybe they should look for in a quality amplifier?
The S logo? No. Actually, I honestly don't care that much. I actually think you should listen to it.
Yeah.
If it works in your system, then it works. It doesn't matter if it's Class D, Class A, Class S, Class whatever. It doesn't matter. If it works for you, then great. If it fits your budget, great. If it fits your size, great. We can't be everything to everyone. There's lots of other, great manufacturers out there. So that's what I'd look for, is something that works for you rather than anything in particular.
The Occasional Podcast is a production of the Part-Time Audiophile Network, which includes PartTimeAudiophile.com, The Occasional Magazine, the PTA Newsletter, and AudioHead.com. You can stay in touch with us on Twitter, Facebook, Instagram, and YouTube. The Occasional Podcast is produced and hosted by Brian Hunter, executive produced by Scott Hall at PTA Productions. If you haven't already, please subscribe to the Occasional Podcast on iTunes, Google, Spotify, or wherever your favorite podcasts are downloaded.